This video corresponds to our optimization problem where we're taking our piece of wire and we want to cut it into two pieces. So we're ready to calculate the intersection. And we have, in your y equals, we want to have 1/16 x squared. So either you use your fraction shortcut key, alpha F1, if you have a TI-84, or you can just put the 1/16 in parentheses. So 1/16 x squared we'll have in our y1, and we have our expectation already that that should be a parabola that opens up. And then the other side is going to be pi, which is right here above your caret button. Pi times the quantity 10 minus x divided by 2 pi squared. So once again, using the shortcut key, alpha F1, if you have a TI-84, or for those of you on a TI-83, you would need a double parenthesis here, because we need to have 10 minus x in the numerator, close parentheses, divided by a parenthesis for 2 pi. So that way we have the numerator in parentheses as well as the denominator, and then we'll close parentheses here because we want to square that entire quantity. And zoom number 6 for our standard viewing window. So here's our parabola, which we expected. And then we should also have a second parabola. And we are interested in calculating the intersection of these two curves. We want to know where these are going to be equal. So this is the point we're interested in. So anytime you're calculating something that you're interested in on a graph, you'll use that calc menu above trace. And this time we're choosing number 5, intersect. So you're going to be prompted for the first curve. So you just pay attention to where the cursor is, where the bug is. And if you can't see it, it always tells you up top here which curve the cursor is currently on. So it doesn't matter where that cursor is, but rather what curve is it on. And yes, this is the correct curve, so we'll press enter. We're accepting that curve. And immediately the cursor moves to the second curve, which has the equation up here. This is its equation, and you can just press enter because yes, that is the curve I'm interested in. And then if there are multiple intersections, when it asks you here to guess, then you would want to go ahead and move the cursor closer to the intersection that you are interested in. If there's only one intersection, then this step is unnecessary. You could just press enter, and it's going to calculate our intersection. So we were interested in solving this equation graphically. So in this case, it's only the x value that we're interested in. We solved this equation and we ended up with an x of approximately 5.3. So now we want to finish the problem, which asked where should the wire be cut. So we're cutting the wire into two pieces. Our first piece should have a length of 5.3 meters. And then looking at your diagram, remember that your second piece of wire, its length we labeled as 10 minus x. So therefore, if you go to your home screen, we want to go 10 minus this x value. And you could type 5.3 in here, but let me show you an interesting feature. Because we used that calculate menu, whenever you calculate an intersection or a maximum or a minimum, the x and the y values are automatically stored in the calculator. So you actually could just type in 10 minus x, and the calculator is going to be inputting here that value that we computed for x, which was about 5.3, but it's going to include all the decimals. So again, you could type 10 minus 5.3, where we took 5.3, which was the rounded answer. That would, of course, give you the second wire has a length of 4.7. Or if you, for some reason, needed more accuracy, this would have been your exact or more exact answer for the second wire. So answering part A, we can say that the first piece should have a length of 5.3 meters, and then we would cut the wire so that the second piece has a length of 4.7 meters. Now, let's go ahead and move on to part B, which asks, where should the wire be cut if the area of both shapes needs to be a minimum? So now we're wanting to take the area of the square and the area of the circle. We want to add the areas together and calculate a minimum. So let's go back to our y equals. Let's clear out what we have here, because now we want to add both of the areas together. So we want to take our 1/16 x squared And now you're going to add it to the second area, which was the pi times the 10 minus x divided by 2 pi squared. So you can kind of test yourself on entering this again. Make sure you don't make any silly parenthesis errors. Once again, that's what it's going to look like for a TI-83. Those of you that are on the TI-84s, let me show that to you as well, just so you can feel comfortable with what it should look like using your shortcut keys. TI-83 folks, I would hope that you would use your shortcut menu, Alpha F1, and choose the first option. And 1/16 x squared, you could enter the 1/16, like so. You could have also entered just x squared divided by 16, of course that would be the same, plus pi, and then you can access your shortcut menu again, so pi times our fraction, which would be 10 minus x divided by 2 pi, and then the whole quantity would be squared. And in fact, I think I would like to go ahead and put that in parentheses. Let me go back. And you can just arrow back if you did something like I did and you want to add the parenthesis in. There we go. That looks a little better. All right, so now zoom standard, but this time we want to calculate a minimum. So now you should have, excuse me, a parabola that opens up, and we're interested in calculating this minimum. So back to second calc, choose number 3 for minimum. Left bound, as long as you're to the left of the minimum, press enter. Right bound, again, you can arrow to the right, or you can just type in an x value that is to the right of the minimum we're looking for, and then press enter on guess. So now it looks like the x value, where we would have a minimum, is here at 5.6. Now be careful, don't assume that 3.5 is your second answer, because remember, the function that we have here in our y equals, this was our area function. So x represents where we would make our first cut on the wire, but y represents the area. So this y value of 3.5 is not our answer. We're interested in 5.6, and then to figure out where the wire should be cut, we need to figure out the other length for the second piece of wire. So once again, quitting, it's going to be 10 minus that answer. So you could type in 10 minus 5.6, and you know that the other length of wire would be about 4.4 meters. Or, once again, because you did calculate using this calculate menu, you could type in 10 minus x, because the x value is automatically stored. And then you could have the decimals if that was necessary. So answer for part B is that our first piece of wire would be a length of 5.6 meters, and our second would be a length of 4.4 meters if we wanted to have the area of both shapes be a minimum.